This is your study guide for 7-1 to 7-3. So as we are going, you are going to want to stop me, catch up before going on to the next slide. Question number 1 says, understand the probability continuum. What do the terms mean? Well, if something is impossible, it cannot happen, which means that it has 0% chance of occurring. If something is unlikely, it probably won't. It has less than 50% chance of happening. If something is as likely as not, that means it's got a 50-50 shot. If something is likely, it probably will happen. That means it has a greater than 50% chance of occurring. And if something is certain, it will happen. It has 100% chance. Now, it's called a continuum because it goes like this. As my chances increase, we're going to move along this line. So we're going to move from impossible. If we get a little more chance, it will become unlikely. A little more chance will be as likely as not. A little more chance will be likely until we have a perfect certainty that something will happen. All right, so you're going to want to pause this and catch up to me before you go on to the next question. Question number 2 says, what makes a game fair? Well, a game is fair if each outcome is equally likely to happen. You don't want anything to have an advantage. Everything is equal. So pause me, catch up, and then go to the next slide. Question number 3 has a spinner A and a spinner B, and we are paying attention to the number 1 sections. So let me find all the number 1 sections on spinner A. There's 1, 2, 3 on spinner A, and there's only 1 on spinner B. So if there's 3 on A and only 1 on B, then I think it's 3 times as likely that pointer A will land on 1 as compared to pointer B. The probability that pointer B will land on an even number, ooh, let me try that. An even number. So that's not even, and that's not even. There are 2 even numbers out of 4, which will simplify to 1/2. The probability that pointer A will land on a 1, well, that's already pretty much done for us, because to get a 1, that's 3 chances out of 8. So 3 out of 8. The next part, I have a mixed bag because I would totally say spinner B is fair. Each section has 1/4 of a chance of being chosen. But spinner A, let's just check this out for a minute. To get a 2, there's 1, 2, 3 2s out of 8. To get a 3, ooh, there's only 1 out of 8. And to get a 4, there's only 1 out of 8. And those are not equal. If they are not equal, that means spinner A is unfair. The probability of pointer A landing on an odd number, all right, let me change pointer A, odd number, odd number, odd number, odd number. That's 4 out of 8, or in simplest form, 1/2. The probability of pointer B landing on an odd number, odd, odd. That's 2 out of 4, which is also 1/2. So it looks like the two probabilities would be equal to each other. Make sure that you catch up to me. So you might want to pause me right here and then go on to the next slide. Question number 4 says, what template can be used to determine the probability of an event? You actually saw this on that Khan Academy of video. So the probability of an event happening is going to be how many times did it happen over total. Question number 5 says, draw a tree diagram showing the outcomes of flipping 2 fair coins. So if I flip 2 fair coins, I can get heads on the first one or tails. If I get heads on the first one, I still could get heads or tails on the second one. If I flip tails the first time, I could still get heads or tails on the second one. So using this probability, how many times should you expect to flip 2 tails if you do 100 trials? It looks like out of these 4 outcomes, 1, 2, 3, 4, only 1 out of the 4 has tails, tails. So how many would that be out of 100? You're going to cross multiply and divide, and your answer is going to be 25 times. Catch up before you move on to the next slide. Question number 6 might look familiar. What is the probability of rolling a product of 4 or greater if you roll 2 fair number cubes? We saw a matrix like this when we were doing sums, but this one clearly says a product. So that means that we are going to be multiplying 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times 5, and so forth. I want you to go ahead and pause me while you get all of these filled in, and then come back and we'll figure out the answer. So out of these 36 boxes, we are looking for everything that has a probability of 4 or greater. 4 or greater. 4 or greater. Keep looking. Keep looking. Keep looking. Keep looking. Okay, now let's count all those up. There appears to be 31 out of 36. Now, I probably wouldn't have counted those up. I would have said there were 36 boxes minus 1, 2, 3, 4, 5 boxes and gotten 31 out of 36 that way. Question number 7 says, tell me everything you can determine when the spinner lands on an even number 145 out of 200 spins. All right, so in theory, to get the probability of an even number, 1, 2, 3, 4 out of 8, or half of them are even numbers. So if I'm going to spin it 200 times, I would expect 100 even numbers. But I got 145 even numbers. So I can say the pointer landed on even more than expected. I can say the expected probability was 50% or 1/2. I can say the actual probability was 145 over 200, which is approximately 73% of them. And those were the evens. Then I can say the actual probability of the odds, if 145 out of 200 were even, then 55 out of 200 were odd, which is about 28%, because, well, let me go back and tell you why. 145, let me change that color. 145 and 55 make the total 200. And then one other thing. In theory, whoops, I changed my color. That's okay. In theory, the probability of even should have equaled the probability of odd. It didn't, but it should have. All right, now that's a lot of writing for you to pause and catch up on. Question number 8 says, Jessica records the number of winners at the Dunk a Teacher booth at the town fair. If there are 250 contestants on Sunday, how many should Jessica expect to dunk a teacher? So we're only looking at Sunday numbers. So it looks like 39 out of 368 dunked the teacher. And we are expecting 250. So all we're going to do is we're going to cross multiply. And we're going to divide. You're going to get an ugly number. Oh my gosh, look at this thing. But remember, we're talking whole people. So we would expect 26 winners, I guess you'll call them. Because you have 26 whole people, but not 27. What are some causes for the difference between a theoretical probability and the experimental probability? So what they're asking here is, why don't you get exactly what you expect? Well, there's two reasons. Luck or chance altered your results, or there were not enough trials. Maybe they didn't do it enough, and so their results were skewed. All right, catch up. We have one last question, so pause me here before moving on. How do you determine theoretical probability and experimental probability? So I'm writing really large. I'm going to go ahead and do my writing down here at the bottom. So theoretical. You are going to determine the number of outcomes in the sample space. And then you are going to put the favorable ones over the total. For experimental probability, we're going to put the number of events that work on top as your numerator, and the total trials on the bottom. Now for both of these, you have to make sure that you are putting things in simplest form. or changing to a percent. All right, go ahead and get caught up, and then you're going to keep this. You may use it on your quiz.